Thank you for coming. We decided to build a line following robot. All five of us, got John Hoy, Adam Lake, Jorge Barron, and James Stewart. We got the idea watching YouTube videos of the competitions they've had at Science Central and other places, and thought that it would be a good one to accomplish. We were also told that no one at this school has ever gotten one of those to work for the capstone, so it gave us a little extra challenge. We wanted to acknowledge the people that had helped us. Rick Brooks is a gentleman that Mr. Etner knows, who is very familiar with these kind of robots. He came in and gave a presentation, showed us his designs. I think he had 3 different robots he showed us, and gave us some tips on how to accomplish ours. Obviously, Mr. Etner gave us a ton of help throughout the whole capstone class, and Mr. Morris also helped some with going over the program, making sure that the program looked good. Basically, we started out with a microprocessor. We decided to use the Basic Stamp 2. It's a 24-pin chip that goes on a carrier board. The carrier board is meant so that it can talk to and from the PC when you want to download the program. It has a RS-232 connector on it. The whole point of the microprocessor, the Basic Stamp, is to control the robot. The program, which James will be talking about in a little bit, decides what tires to spin at what speed, when to reverse them. I believe it's pins 4 through 15 are the pins used to control the output of the motors, as well as the sensors. We basically used pins 4 through 7 to control the sensor circuit. We used jumper wires to go from the Basic Stamp board down to the sensors, and we used pins 12 to 15 to control the motors. 12 and 13 controlled the left motor, and 14 and 15 controlled the right motor. Those signals are sent to the H-bridge, which James will also be talking about. The Basic Stamp can use anywhere between 5 and 12 volts DC. We decided to use a 9-volt battery since the connector was already on there. Pin 24 received the positive voltage from the battery, and VSS pin 23 was the negative, and we also wired that to the chassis ground. This is our schematic. As you can see, up here in the corner is the RS-232 that connects to the PC so you can download your program. Pin 2 is the receive, and pin 3 is the transmit. These here are the pins for the sensors, and these are the ones for the motors here. And our power supply up there in the corner.
For the H-bridge, we needed 2 H-bridge circuits to control the motors, and the H-bridge receives its signals from the Basic Stamp. For each circuit, it is comprised of 2 5305 MOSFETs and 2 2703 MOSFETs. They're used in sync with each other for their high current capabilities and their high-speed switching. There are 4 rectifier diodes that are used to convert the AC signals coming from the MOSFETs to DC signals for the motor. The DC motor assembly is powered by a total of 6 AA batteries. The motor themselves only require 7.2 volts to operate. By using 9 volts, it'll give the motors more power to carry the load, as well as provide enough power for the rest of the H-bridge circuit to operate. And right here is a schematic of just one of the 2 H-bridges. And right here, R2 and R4 would go to the Basic Stamp, which would be for the left motors pins 12 and 13, and for the right motors pin 14 and 15. Right here and here Our 2703s, and up top are 5305 MOSFETs that go to our 4 diodes in the center to the motor right there. And
basically for the sensors, what we decided to do, since we couldn't get part in the front that had both the photo transistor and the infrared LED, we decided to make our own. So we just got a infrared LED and put it next to the photo transistor. We have a 9-volt power source going into a 5-volt regulator, which constantly applies power to the infrared LEDs, so that when the photo transistors capture the reflection off of the whiteboard or the tape, it'll then decide whether it's on or off. Once it then determines that, it goes to the microchip that we have, which tells the basic stamp what the outputs from the photo transistors were. So that tells it which direction to go, when to turn, when to go straight, when basically everything that drives it is in the sensor. This is the sensor circuit. This is just one of the sensors going into the LM741CN. This is your photo transistor and your LED, which will be on the bottom of the robot, so it senses the line.
there's a better view of our H-bridge sensor circuit, sensors up front there, and our basic stand. And right here we have our parts list, what we required other than what we had in our toolboxes.
I think I picked up some hair.